Okay, got a request from a student to make a video about this topic, predicting the qualitative acid-base properties of metal cations. All right, so first thing I'm going to do when I get something like this is I'm going to make notes, right? I'm going to take, let's do ammonium chloride first. I'm going to come over here and say ammonium chloride. And the first thing I'm going to do is I'm going to think about this. If it's acid-base, it's going to be aqueous. This is really the same thing as ammonium, right? And chloride, right? Okay. Now, the chloride itself is the conjugate base of HCl, right? I know that because I tack a proton on there and I see it, all right? It's the conjugate base of HCl, and HCl is a strong acid. In other words, the chloride's very comfortable by itself. Therefore, the base is unreactive. Okay, we'll do that again with the other ones. Okay, now let's look over here at this cation. Well, this is the conjugate acid of a weak base, namely ammonia, right? And so therefore, this is clear what I'm doing here. Therefore, this is acidic. All right. So again, in review, what I did was I took my ammonium chloride, I divided it up into its two ions, and I considered them each separately. This is the conjugate base of HCl, which is a strong acid, and so consequently this Cl chloride is unreactive, and it's essentially not going to take any part here, okay? But this is an acid. I know, because it's the conjugate acid of a weak base, ammonia. All right, so let's go back over here, and let's choose, let's say that's acidic, okay? Now, sodium hydroxide, let's take that one. Let's go back over here, and we'll add a new layer, get rid of that one, and we'll say sodium hydroxide, okay? Now this is the same thing as sodium and hydroxide, okay? We know that sodium, let's consider these guys separately. We know that sodium is strongly soluble. It always acts as a cation, always acts, as a spectator ion. Okay, and therefore it's unreactive. Okay, so this is essentially not going to take part in it. Sodium never does. Okay, but this is why. It's always soluble. It always acts as a spectator ion. It is unreactive. Okay, now hydroxide, well, that's the very definition of a base, right? That is something that produces base in solution, okay? That's the definition of a base. So let's go back over here and say that that is basic, sodium hydroxide. Now let's do potassium bromide. We'll do the same thing. It's going so fast I might do another one. Potassium bromide, which is really, right, potassium and bromide. Okay, let's go with a different color now. Okay, this is always soluble, just like sodium. It's always a spectator ion, always. Okay, and it's therefore very unreactive, extremely unreactive in solution. So this is not relevant to us. Bromide, aha, this is the conjugate base of a strong acid, right? Just a second here. Of a strong acid, right? I know that because I tack a proton on here. That plus that gives me HBr. And we know that when HBr hits the water, it goes to that and bromide is never reacting with the proton, okay? So therefore, this is unreactive. Can you see that? Unreactive. So consequently, this is going to be neutral. Neutral. All right? So this was acidic because the chloride was unreactive, but that's ammonium, which is acidic. This is basic because that's unreactive, but hydroxide is a base, right? This is neutral because both of these are unreactive, bromide and potassium. All right, let's do one more. Let's check this first. I'd like to see the green on there. Bam. Let's do more practice here for this one, and then we'll move on, okay? So let's go back here. Okay, ammonium iodide. Ammonium iodide. Ammonium iodide. So what I'm going to do is I'm going to say, this is really ammonium plus iodide, right? Let's go here now in red, and let's think about these two guys separately. Okay, well this is the conjugate base of Hi, which is a strong acid, right? So if that's a strong acid, therefore this iodide is very unreactive. Okay? Ammonium, on the other hand, is the conjugate acid of a weak base. Okay? And that means it does react. It is going to actually act as an acid, okay? Okay, we've been doing this a lot in a lot of different contexts, so I think I'm not going to say anything more about that. Let's just go back here and say that's acidic. Okay, potassium nitrite. Let's look at that one. Okay, potassium nitrite. Okay, first thing I'm going to do, same as always, right? So I'm going to say, well, really this is potassium and nitrite. Okay, and these hopefully look familiar after dealing with them a good bit. Potassium's a spectator, always unreactive. Potassium and sodium. Now I didn't tell you why, but the explanation in Alex tells you why. It's because it's tiny. It's tiny, 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 and it is not. It doesn't want. It's completely hydrated. It does not want to. It doesn't want to react with anything at all. Okay, but nitrite now, what's this? Well, this is the conjugate base of nitrous acid, HNO2, which is a weak acid. Well, my handwriting is terrible, isn't it? Let me go back and do that one again. Pretend like this is HNO2, which is a weak acid, right? And therefore, this is going to be basic, right? The conjugate base of a weak acid is somewhat basic. Okay, let's go back over here. And so the potassium was unreactive, but this was basic, and so this whole thing is going to be basic. All right. Let's do the same thing with sodium nitrate, which looks a lot the same, with an important difference. Sodium nitrate, which is really sodium and nitrate, right? So let's come over here. Okay, this is unreactive. Sodium and potassium, right? Completely soluble. It's always a spectator ion. You should write notes out like this. If you're not clear on it, you should write notes. It's very, very common. I see students who understand stuff but don't write enough down, and so they get sideways. Unreactive, it's spectator, and so it's not interesting at all. Nitrate, on the other hand, is the conjugate base of nitric acid, which is a strong acid. That means that that means that the conjugate base, nitrate, is unreactive. Okay, so it looks like both of these are unreactive. This one's going to be neutral. Sodium is unreactive, and so is nitrate. So this is going to be neutral. All right, let's get some green here, and then we'll cut this video off. All right, if you want more explanation for that, you really should, of course, read the explanation. Alex's explanation is good and thorough, but do call me back, or rather send me a note and say you want more explanation. All right, good luck.